All right, we are in the last section of the last chapter of the core material that you need to know for papers 1 and 2. Everything after this point will be for HLs only, and it will be material for paper 3. So we're going to talk about Z distribution, and this is mainly something you're going to have to do if you ever have a normal distribution question, but it is a non-calculator normal distribution question. And what you're going to need for that is you're going to need this table right here. It will be provided to you on your tests in my class, but it will also be provided for you in some form on the paper 1 where you don't get to use a calculator. So this is the table you'll have. It's a little bit overwhelming at first, but I'll show you how to use it in an example. First, let me tell you what this table actually shows. It shows a normal distribution where the mean is 0 and the standard deviation is 1. And basically, if you plug in or if you look up any number from -3 to 3, then it will show you the area under the curve that goes to the left of that x value that you're looking up. So let's say you looked up 1.5. Then it would show you the area under the curve from -infinity to that 1.5 that you're looking at. And that represents the probability that any x is below that 1.5 value. So the problem with that is that's the only distribution that it does, is it only does the normal distribution where the mean is 0 and the standard deviation is 1. So how do I use it if I don't have that mean and I don't have that standard deviation? Well, all we have to do is convert from our normal distribution to the one that's on the table, and that's called the Z-score. Here's how you calculate it. Whatever your value is that you're looking up, we'll call that x, and we'll call the mean mu, and we'll call the standard deviation sigma, just like we have when we were talking about normal distributions. So simply calculate this, take your x, subtract mu, and divide by sigma, and you will get a z-score somewhere between -3 and 3. Now let me explain why this works. If you remember when we first started talking about normal distributions and I showed you that bell curve, what it said, what was on the x-axis were these numbers right here, mu minus 3 sigma all the way up to mu plus 3 sigma, and those were the tick marks that were on the x-axis in that normal distribution curve. So what happens when I subtract mu from all of those is that the mu's simply go away, and I'm left with everything from -3 sigma up to +3 sigma. And then when I divide all of those by sigma, I just get numbers from -3 up to +3. And so it's the same curve, it's just that now all of the x's on the x-axis are numbers from -3 to 3. So I just have to remember this is how to calculate my z-score. All right. So looking at an example, if I have clay vases that are produced in a factory, I give you the mean of 50 and I give you the standard deviation of 1.5, and I want to know the probability that a vase weighs less than 52 pounds. So I'm going to use 50 as my mu, 1.5 as my sigma, and 52 as the x that I'm looking up. And if I plug those in to that z-score formula that I just showed you, I will get 1.33, and I will round to the nearest hundredth because that's as far or as accurate as the table goes. It only goes to the hundredths. All right, so I'm going to take this number to the table and I'm going to show you how to look it up. Remember, the number was 1.33 actually. So I'm going to look up the ones column and the tenths column down here, and I'm going to look up the hundredths column across here. So if it was 1.33, then this is the row that 1.3 is in, and then the hundredths column was also a 3, so I'm looking here, and I get a value of 0.9082. So that's the probability right there. All right. So what if I wanted the probability that a vase was more than a given weight? What if I wanted the probability that a vase was between two given weights? I want you to think about that because I could also ask you questions like that. All right, and if you aren't sure, you can certainly ask me about that between now and tomorrow, but I do want you to think about it a little bit before you ask me right away. So now let's talk about the opposite kind of question. We talked about a question where I wanted the probability that a vase was below a certain weight. Now, if I give you a percentage and I ask you for the weight that that percentage of vases is less than, then I need to know how to do that. So let's say I wanted to know 22% of the vases weigh less than what amount. So what I need to do is, instead of looking up the row and the column, I'm going to need to look actually inside the table and see what row and column that percentage is in. So it's kind of the opposite of what I did before. So let's go to the table and look for something that's close to 0.2200. Well, if I look, it sometimes takes a while to find, but I do eventually find 0.2206, which is really close to 0.2200. And so what I do is I look at the row and the column that's in, and it's in the row that starts with negative 0.7, and it's in the column that has 0.07 at the top. So if I combine these, I get negative 0.77. And so that's my z-score. That's my number that's between -3 and 3. So I just simply need to convert that back to an x-score where the mean is 50 instead of 0 and the sigma is 1.5 instead of 1. So let me just change that page width, sorry. And so if I plug those into this formula again, x is what I'm missing. So negative 0.77 will equal x minus 50 over 1.5, and so my x value is 48.45. So 22% of the vases are less than 48.8 pounds. So that's both ways of using that chart that you're allowed to use if you don't have a calculator. If you have any questions, please let me know, and I will see you tomorrow. This is the last lecture for the SLs for core, so feel free to celebrate any way you want to, and I will see you tomorrow.